So in this question we're given a diagram of a parallelogram with ABC at midpoint of AB is M, and we're told that the vector lowercase a is the same as the line segment OA, and the vector lowercase b is the same as the line segment OB. We're then asked to give the various line segments in terms of the vectors A and B. So the easiest way to do these things is to try and work out or give each path or line segment in terms of an equivalent path. So we look at B to C, it's the same length and distance as A to O, so we can say they're equal. So that would be the same as the line segment AO. And the line segment AO would be A but in the opposite direction, so we call that negative A. Okay, we move on to AB. So if we want to go from A to B, what we could do is go from A to O and then O to B. So there's an equivalent path or line segment, so it's AO plus OB. And we've just worked out AO is minus A. And we're told in the question that OB is B. And then last but not least, M to C. Okay, so if we want to go from M to C, we could go M to A, then A to O, and then so we go from M to A to O, O to B, and then last but not least we go B to C. Now why I went in this method is we actually know all of these. Okay, so if we have a look, M to A is half of B to A. A to O we know is minus A. O to B we know is B. And B to C is minus A as well. Okay, now half of B to A is the opposite direction, is going to be minus a half A to B. And simplifying this, minus 2A plus B. So it's equal to half A minus a half B minus 2A plus B. So it's equal to minus 1.5 A plus a half B. Okay, now move on to part 2. And what we're told in part 2 is BC gets produced down to some point M, and the ratio of BC to CN is 1 to 2. So in other words, this length is going to be actually twice this length. So we're asked, prove MC and ON are parallel. Now the way you show that any vectors are parallel is you show that one vector is a multiple of the other. So we already don't know what MC is, so we'll have to work out what ON is then. So to get from O to N, we can go O to B and then B to N. Okay, so O to N is same as O to B plus B to N. Okay, now O to B we know is just B. And B to N, well, B to C, we know they're in the ratio 1 to 2, so B to C is 1, so B to N would be 3 times B to C. Okay, so it's equal to B plus B to C is plus minus 3A. So ON is equal to minus 3A plus B. Now you should notice that if I multiply ON by half, I get AMC. Oops, AMC. So, as ON equals a number times MC, they are parallel. Okay, so just go over that again. We notice that when I multiply ON by half, I get the same vector expression as MC, so they must be equal. So half ON is equal to MC, so ON is equal to something times MC, so they're parallel.